Hello, everyone. The plan for today is just to do a few examples practicing using the chi-squared test in Minitab. Um, so I have two where our data is summarized in a table, and then one where we're going to try it using some raw data. So um, rather than type everything out like I normally do, there's a lot of numbers here, so I just sort of copied and pasted it from the PowerPoint that I would have used if we were in a classroom into my Word document. So this is data that I pulled off of the web from a project called, it was like a big social science survey. I think it's called like the General Society Survey or something like that. They just had a huge amount of data with a bunch of questions, not really science-y, more sort of like demographic and political type questions. So two of the questions that they had on there was, what is your marital status? The options were married, widowed, divorced, separated, or never married. And then a second question that I pulled off of there was, are you satisfied with your financial situation? And the options were satisfied, okay, and not satisfied. So this table sort of summarizes what people answered. So for example, out of the 3,000 total people who answered these two questions, there were 615 who said they were married and they were satisfied with their financial situation. So the question is, does your marital status, is there some kind of association between your marital status and how you feel financially? I mean, intuition tells you that perhaps, for example, someone who is divorced, that might tend to upset their financial situation. So maybe they would feel less stable. And looking at the table, it kind of looks true. There's more in the not satisfied than the satisfied category in this divorced and separated category than there is compared to married. There's more satisfied and not so many not satisfied. So, but there's a lot of boxes in this table. Like there's 12 boxes in the main body of the table if you ignore the totals columns. And it's hard to sort of look at 12 boxes and see if there is a real association. So remember, the way the chi-squared test works is it sort of looks at the totals in each of these columns and then compares that to the proportion in each of the rows for each of the subcategories, and same thing kind of going the other way. It would generate what you would expect in the middle if everything was proportional to the totals, and then see how far the actual data was from those expected values, where what you would expect if there were no association at all between the two variables. So before we throw this into Minitab, one other thing I want to say is that there's a reason that this middle category here is divorced or separated. When I first got the data, there was separate answers for divorced and separated. Now, I first pulled this data off the web like 10 years ago when I was teaching in a different stats class, and I've lost track of the original data, but there were very few answers in the separated row. You know, separated was just not an answer that came up that often. And it meant that that row had small numbers in it. It might even have had a 0 or 2. So if I put that into the chi-squared test with those small numbers there, particularly if any of the boxes had 0, it would give me an error. The chi-squared test does not work if there's any zeros there. And if there's small numbers, it runs, but it's not like, I don't understand the stats theory well enough to say why, but it's not as reliable as to how it tests the association. So my solution was to take the separated and divorced people and put them together in the same category for marital status, because I figured separated and divorced were somewhat similar in terms of how they might feel about their financial situation. Another option would have been just to get rid of the separated people altogether, say, you don't get counted in this analysis because there's not enough of you for my stats analysis tools to work. But the solution I did was to put the divorce and separated together. All right, so what I'm going to do is put these numbers into Minitab. So what I have to do is get the table into Minitab, and not the whole table with the totals, just the columns for the 3 answers up here, satisfied, okay, and not satisfied, and the rows for the different options for marital status, not the totals. So I could type them in, but it would be faster just to highlight these 12 boxes, copy, whoops, not there, copy, and then paste it over into Minitab. Now, you should be able to open up this Word document from my webpage. That's where you presumably got the links to my YouTube videos, unless you're subscribed to the channel. You can open up the Word document. You can also copy and paste into Minitab. So I'm going to flip over to Minitab and then paste over in there. Okay, I can't see much of my spreadsheet down at the bottom, so I'm going to move that up a bit, move my cursor so I get the little move arrows, make the table a little bigger. And then if I just do paste here, it should fill it in boxes, I think. Edit, paste cells. Yep, so I just chose edit, paste, and it filled in those 12 boxes that I copied. Once you have the data into the table below here, it's pretty easy to run the chi-squared test. If you tried it with the last set of videos, then you know what to do here. We just go stat, tables, chi-squared test for association. There's other chi-squared tests here. We're using chi-squared test for association. I don't have the raw data. I have this summarized in a table. So we'll check summarized data in a table. And there was nothing appearing over on the left, but when I clicked in this box to enter the columns that have the table, then the stuff that has writing in it appeared over here on the left. So I want my tables in columns C1, C2, and C3. So C1, select that, C2, select that, C3, select that. So C1, C2, and C3 have my table in them. I purposely did not copy over labels. So if you had copied the entire table, like including the labels on the top and side, you might have to adjust for that. Tell Minitab don't try to include those in the computation. But I figured the easiest thing is to just get the important numbers in there and not copy the labels. I'm going to flip into the statistics button just to double check that this stuff looks okay. Running the chi-squared test. We're going to have the counts. We already have those. Marginal counts. Those are the totals, so it's going to regenerate the totals. And expected cell counts, that sounds good. We want the expected number that we're comparing to, that we would expect if they're independent. And I think last time I checked this raw residuals, we'll see how far away our numbers are from the expected numbers. So we'll hit OK, and OK again to run our test and see what we get. All right. So in that top left box, which was the married and satisfied with their financial situation, we had 615 in the box. We were expecting 562, so it was higher than expected by 52. And the not satisfied box was lower than expected by 70. So the married group were sort of skewed over to the satisfied side. The okay people were closer to the expected number. And then the widowed group, their numbers don't seem too different. I mean, of course, the number that they're off is smaller because the totals are smaller, but they're really not that far away. They're within 10, they're close to 10% off. The top ones are close to 10% off too. The divorce numbers are way off. We were expecting 101. It was 60 in the first column. That's almost double. And in the last column, we were expecting 100, or we were expecting 80, and said it was 135. Again, not quite double, but it's a big chunk. It's a lot more than 10% difference. And then the bottom row, not so different. Again, maybe that's 20% away. We had 159. That was 20 lower than we expected. So that's maybe 15% or something. So most of these numbers, except for the divorced and separated row, are within about 10% of what we expect. So is that far enough away for us to say there's evidence of an association? Well, let's see what the p-value is. P-value extremely small. So remember, we're using the Pearson one. That's the chi-squared test we were using. This is 0 to a gazillion decimal places. I had to go out to like, it looks like it's like 12 decimal places out before you start getting numbers. Now, I should say that when you have a really big sample like this, like 3,000, you're typically going to have evidence of an association. You typically end up with small p-values unless these numbers are really, really close. So being off by 10% out of 3,000, that's usually going to say that you have evidence of an association. The association might not be very strong, but it's enough for the chi-square test. So for this first example, we do have strong evidence of an association. This DF, we're not going to use that a lot, but that stands for degrees of freedom. In the table here, let me just look at the table at the bottom. If you sort of look at how big the table is, leaving out one row and one column, the number of cells you have left is the degrees of freedom. And what that means is basically if you fill in 6 of the boxes from this table and also the totals, then you can figure out the remaining boxes. So that's why there's 6 degrees of freedom. If you know the totals and 6 of the boxes, then you could figure out the remaining, in this case, 6 boxes. So the degrees of freedom is how many boxes you need to know in addition to the totals to figure out what all the other boxes were by sort of adding everything up and so forth. And the reason that's significant is just because, like, in the formula for generating a p-value using the chi-square distribution, the degrees of freedom is an important part of it. Okay, so that's enough for this example. We'll do another similar example in the next video.